Hello, students! So this little lesson here is going to be about factoring differences of squares. The reason I have on this beautiful face mask here is because I have people in the room and we want to follow all of these safety and health guidelines. So first off, let's just kind of get a good definition of what difference of squares actually is. What is a difference of squares? So a difference of squares is where you are subtracting two perfect squares. Mr. Starkey, what is a perfect square? So I'm glad you asked. A perfect square is the result of multiplying either the same number or the same expression by itself. In other words, a perfect square is the result of squaring some type of expression. Some of you may be thinking, okay, Mr. Starkey, you're going to have to help me. I'm a visual type of person. I need to see what you mean. Okay, I need to see some examples of what perfect squares are. Okay, well, I will show you just that. Okay, so let's just look at a few numbers and a few expressions that would be considered as perfect squares. So let's see, the number 1 is a perfect square. Why is 1 a perfect square? Because technically 1 is the result of multiplying 1 times 1. 4 is the result of multiplying 2 times 2. 9 is the result of squaring 3, right? 16, 25, 36, 49, 64, the list goes on. Okay, so if you're looking at some of these numbers and you're like, okay, Mr. Starkey, I know that some of these numbers are the result of squaring another number. Yeah, so you've been looking at perfect squares when you look at numbers like this. Now, numbers or constants are not the only type of perfect squares. What I have shown so far are just constants, just numbers written without variables. Variable expressions can also be considered perfect squares as well. Like for instance, x squared. X squared is the result of multiplying x times itself, or squaring x. Okay, x to the 4th is the result of multiplying x squared times x squared. In other words, where you square x squared. X to the 6th is an example of another perfect square. In other words, if you have a variable expression and the exponent is an even number, like x squared, x to the 4th, x to the 6th, x to the 8th, and then also we can have a combination of constants and variable expressions where it's written all as one expression and it's still considered a perfect square. Like for instance, you could have something like 81 y to the 8th, x to the 14th. And again, most of the times you probably wouldn't have to do something like this with a perfect square. Well, I won't say that, but because you may see something like this on your final exam. So, hey. So if we had that expression, again, 81 is a perfect square because 81 is the same thing as 9 multiplied by itself, right? So you have 9 times 9, that gives you 81. Okay. The y to the 8th power, okay, that's a perfect square because that is the same thing as y to the 4th power multiplied by itself. And then x to the 14th is a perfect square, that part of it, because that is x to the 7th multiplied by itself. So again, it is the same thing as multiplying 9y to the 4th, x to the 7th, times itself. And again, this may look a little abstract because it has numbers and it has variables in it, and not just one variable. It has 2 variables. You might be thinking, Mr. Starkey, what are you doing? If they're perfect squares and you see one of these and then minus or subtracting another one of these perfect squares. So again, if it looks like a perfect square minus another perfect square, then that is what we consider a difference of squares. So again, that's just a little background information. We're going to look at an example or two. Oh, my guests are gone now. All right, so you can see my face again. Determine if the expression is a difference of squares. So before you can factor a difference of squares, obviously you got to actually be able to recognize that it is a difference of squares, right? So if we're looking at this example here and we're trying to determine whether or not this expression is a difference of squares, first off, it is a binomial. It has a difference of two terms. Check. Okay, so it's a binomial, it has a difference of two terms, check. Now, we got to check to see if those two terms are perfect squares. So, if we can write this this expression in this form, something squared minus something squared. Okay, again, folks, we said that in order for it to be a perfect square, it has to be some number that's the result of multiplying the same thing times itself, or in other words, the result of squaring something. So, is 64 the result of squaring some number? Okay, if you're unsure about that, what you can do when it is a number, when it is a constant like 64, what you can do is you can take the square root of that number, right? So, just a little side note, just kind of take the square root of a constant like 64. The square root of 64, if it is a whole number, then you know it is a perfect square. The square root of 64 is equal to 8, which means that 64 can be rewritten as 8 squared. Okay? That should make sense. All right. Now, so that's what you can do when it is a constant term, a term that's written without any variables. When it is a variable, if it has an even exponent, okay, then you pretty much know that it is a perfect square. What you can do is just divide this exponent by 2. So in other words, the exponent here is 2. Divide whatever that even exponent is by 2. Okay, 2 divided by 2 gives you 1, right? So it's x to the first power, right? So this expression can be written again like this. 8 squared is 64. X squared is, of course, x squared, duh. Okay, so yes, it's a perfect square, okay? Before we look at this second one, where we're determining if the expression is a difference of squares, again, folks, you have to know that it's a binomial. It's got to be the difference of two terms. In other words, it's got to be where you're subtracting two terms. Now, when you're talking about the difference of two terms, that first term has to be positive. The first term in that difference must be positive. And also, you have to make sure that both terms are perfect squares. Okay? So again, both terms must be perfect squares. All right, so let's look at this next example. All right, so again, in this first one, we met all three criteria. So yes, we know that it is a difference of squares. So if we were asked to factor that difference of squares, then it could be factored as a difference of squares, because it is actually a difference of squares. All right, let's look at this one here. Let's look at our three criteria. Figure out, is it a difference of squares first off? Because if it's not a difference of squares, then it can't be factored as a difference of squares. So, is it a binomial? Yes. Is it a difference of two terms where the first term is positive? Well, yeah, you got a positive something here and you got subtracted or minus, it's a difference. Yeah, you got two terms subtracted and the first term is positive. Yeah. And now, are they perfect squares? Remember, we said that that to determine if they're perfect squares, it has to be you have to be able to write it out in this form, right? And the best way to write it in this form, where you have something squared minus something squared, is to take the square root of the numbers. So the constants that you see, 196, 16, take the square root of those. If those give you whole numbers, square root of 196 is 14. That's a whole number. Okay, what about the square root of 16? that gives you 4, right? So that's a whole number. So that's one part of it. And so we're able to take the square root of those numbers. And then are we able to divide the exponents by 2? Can we divide the exponents by 2? Okay, let's look at this. We got x to the 6th power. Okay, well, yeah, that's x cubed. So that one works out. 14. And then if we divide that exponent by 2, we get x to the 3rd power. What about this exponent? What's the exponent here? 1? Oh, snap. It's a little hard to divide 1 by 2. Or at least it's not hard, but we don't get a whole number if we do that. So because this exponent here is not an even number. Again, this exponent is 1. It's not an even number. It's not going to work. These are not perfect squares. This one, the first one, can be written in that perfect square type of form, but this second one cannot be written like that. The second one cannot be written like that at all. Okay, so they're not perfect squares. So this one here does not work out at all. We are not able to divide our exponents by 2, or at least we're not able to divide it evenly, meaning we don't get a whole number. So again, folks, this second example here is not a difference of squares because even though it meets most of the criteria, most of the requirements, this exponent here for the x, it is x to the 1st power. That exponent is not even, which means you cannot divide that exponent by 2. Even though we were able to divide, that first exponent by 2, we can't divide this one by 2. At least not evenly. Okay. So, when we are talking about factoring a difference of squares, so first off, if we know that it is a difference of squares and we're able to identify, that it can be written in this form, something squared minus something squared, then we can actually factor that difference of squares, and we can write out the 2 factors for it. If we do have a difference of squares and it can be written in this form, then the 2 factors will be a plus b. And notice you don't see any squareds here for the factors, right? Good. And that doesn't mean. Okay, and we'll talk more in examples where you can see a times b and a minus b. You don't see any squareds here for the parentheses, but anyway. All right, we'll do a few examples in the next video. I hope that this has been helpful with just what difference of squares is, with what a perfect square is. How to identify whether or not you've got a difference of squares. And then here, again, I know this may not be helpful to you right now, but again, you will see exactly how to use this particular formula. Gotta love those bells. But again, you will see how to use this particular formula and how to actually factor difference of squares in part 2 of this lesson. Okay, so in the next video. All right, see you soon.